Okay, we are going to start with a general friction problem. So we're going to say there's an object on the ground being dragged across the ground with an applied force solely in a horizontal positive x direction. Alright, and so our free body diagram here, we have friction, we have Fg, and we have Fn. Okay, that's our general for a horizontal applied force. So let's make some givens. We'll say the mass is 20 kilograms, which gives us an Fg of m times g, which is 20 kilograms times 9.81 meters per second squared. So our Fg for this problem is 196.2 newtons. Alright, we're going to set up our net force equations. Let's start in the x. We have Fa minus our F of F. And let's say we know we're moving. Okay, so if we know we're moving, it's not equal to 0. We're going to set that equal to ma because we have an unbalanced force, which means we have a net force in the x direction. Alright, net force in the y. We have Fn acting in the positive direction and Fg acting in the negative. We know that's 0 because we're sitting on the ground. That's given in the problem. So if we're sitting on the ground, if we're accelerating in the x direction, in the horizontal, we're not accelerating in the y, so that's equal to 0. So from this equation here, we can make the statement Fn equals Fg. So we already know our Fg, so we know our Fn here is 196.2 newtons as well. Okay, so let's say if we're just in general, we have a coefficient, we're going to say we're moving, we're going to say coefficient of kinetic friction of 0.3. Okay, if we want to find the acceleration of this object, and we know there's a certain push on this object, so we're going to need the force of friction here. So let's say our applied force on this is 120 newtons. So we want to find our acceleration. That's what we're looking for. So if we're looking for our acceleration, we know our applied there. We know our coefficient of friction, so we can find F of F. So we want to find F of F next. Mu k times the normal force. So our force of friction here is 0.3 times 196.2 newtons. Comes from this right here, which we found. So our force of friction in this case is 58.86 newtons. So we are correct. We have an acceleration because the applied force is much greater than the frictional force. So if we go to here, we know that is the amount of the unbalanced force. So let's redo our net force in the x. So we get 120 newtons minus 58.86 newtons. We can set this equal to MA right here and solve, or we can find this value. So if we find this value, 61.14, this is our unbalanced net force. Unbalanced force causes our acceleration. Okay, so that's this value right here. So then, to find the acceleration based on our 20 kilogram mass, we go to Newton's second law. Net force equals m times a. We want to find a, our net force, divided by m. So we get 61.14 newtons divided by 20 kilograms. And our acceleration is 3.057 meters per second squared. So that's about as general as we can get. We start from a horizontal push. We solve our normal force to find our force of friction, plug that into the net force in the x to find our unbalanced net force, and then solve Newton's second law for acceleration.